Hi there. I'm Mark. I'm a former software engineer. I'm now a maker. I'm building a prototype of a device. It kind of looks like this. It's a smart drone enclosure that lets you shelter your drone when you're not flying, and then it opens up into a flight deck with telepresence so you can remotely fly. And it's got these motions in it. So after working on the mechanical engineering side of it for a while, I've come back to the software side and took a crack at it using the new version of Django. So I just wanted to kind of show what I've been working on, and it's kind of hilarious that following Summit to talk about now a Raspberry Pi, so completely different, opposite platform. You know, when you look at robotic motion, even this little thing here where I'm extending a sensor mast, it's a fairly complicated thing. You've got 5 motors that are working simultaneously. You've got the sled coming out, the pivot, then it extends upward, and then there's a gimbal that has to keep the camera level as that motion's taking place. There's a lot of stuff going on. Plus, it's accelerated, acceleration curves and things like that. So you can think of event-driven, and I'm going to hand wave and say I didn't use ROS or G-event or things like that. But I'd always been using Django and the Django REST framework to put a RESTful interface on top of this device. So I thought I'd take a look at Django 2, which had been rewritten for async I/O. Wanted to learn async I/O, so I implemented it with that. So as you do, I started with an ERD. And basically, the basic idea of the framework is that the key concept is that the framework takes devices and motions, and it represents them in a class structure as coroutines. And I'm going to hand wave again because the device part of it is where the complication is down in the framework, because a lot of times the trickiness with creating a device that's an asynchronous device is that they often have to operate through a synchronous library like curses or PyGPIO or something like that. So whenever you're talking to real hardware, you're generally going to be thread wrapping those things. So I won't talk about all that. That's the complexity down in the framework. What I want to talk about are 2 of the classes, the base classes that are in there, motion plan and nodes. So a motion plan is simply a sequence of nodes. They run one after the other. And then each node encapsulates a set of coroutines that all run in parallel. And that's how motion is represented. And just with that quick description, I'm going to jump right into some code. And I'll just show you. And once you've actually represented that in the framework, it turns out once you come up into motion plans, it actually turns out to be a fairly clean representation of motion. So if I take a look at a motion in this, if I go back over here, if I look at this motion here, which is just opening the roll top, just that right there, okay? That's actually 3 devices in play. There's a roll top motor, there's a limit switch when the thing is closed, and we'll call that switch 1. And then there's another limit switch when the thing opens, we'll call that switch 2. And in the code, basically looks like this. So this is how you represent an open roll top motion plan. Each motion plan has a set of devices that you list. Those have to be checked out of a registry. There's a 0 starting state, which is done with a set of asserts. So here we're making sure that the switch 1 is 0, or is closed, so the roll top is on it. And from there we do the first node. And the nodes basically represent substates that your device needs to move through on the way to transitioning to some other larger new state. And so the node basically lists a set of coroutines that run. And in this case, all we do is we start the motor running, and we listen for a switch being closed. But I want to illustrate here that the coroutines that could run in the node could be as many as you want. You could start 10 motors. You can start 20 motors, all that you want. And then, so we listen to a certain event that'll transition the node. And we give the node a certain amount of time to complete or to transition out of it. If we don't finish, then we crash. We listen to the switch to close, switch 2. When it does, we transition to the next node, which stops the motor. and that's pretty much all it is. So if I do a quick demo on this, oh yeah,
Okay.
done. Very quick.
All right.
There we go. So that's a very quick run of that. That actually motion plan just ran. It closed, opened the roll top, and then we're done. Anyway, it's a pretty simple framework. It's fresh out of the oven. I'm going to be at the PyMaker happy hour. If any of you have any questions on how to run a quick robot on Raspberry Pi, I'd love to talk to you. Thanks.